and we can start getting ready for the second workshop today, which is from Recall. So I saw a message in chat during that break that Grace is here to learn about Recall, which is good because that's what we're going to do now. So I'm going to invite our speaker, Mark, up to the stage to join us. And then we'll jump right into our final workshop in the AI Blueprints Hackathon. And then we're going to get into the building part, which is the most fun part, of course. Hi, Mark. Thanks for joining us.
Hey, how is everyone?
I think everyone is doing well. We can get started when you're ready. So feel free to share your screen and hopefully people are back at their chairs, back at their desks.
Cool. Super excited about this. Let me know once you can see my screen.
Yep, looking good.
Okay, awesome. So for those of you who might have missed the intro at the beginning of the week, my name's Mark. I'm a partner engineer at Recall with Textile. And what I wanted to walk through today is kind of a modified version of this initial workshop overview that I gave. And I also definitely want to leave time for people to ask questions or, keep things open-ended. I'm not sure if it'll take the full 45 minutes, but I'll kind of start just by introducing Recall and then also talk a bit about our bounties. So you might have seen our bounty overview. And at the beginning of the week, I spoke about how Recall is an intelligence network for AI agents that allow them to collaborate, share, and monetize their memories, their chain of thought logs, different artifacts that come out of agent operations, ultimately with the aim to improve and increase collective agent intelligence. And so really what we're looking for are just creative ways of integrating Recall or creating new open source tooling that makes it easier to work with Recall. Things are a bit open-ended, and I left that intentionally so. So if anyone has questions about different ideas, please hit me up in the Discord and we can talk more about your ideas. I gave a few examples and I went over this towards the beginning of the week, but really the main constraint here is just making sure that you're logging chain of thought logs to Recall. And to make that a bit easier for you, we created actually a few iterations of a Recall agent starter kit, which for those of you who have used the ELIZA agent starter kit, this is a kind of a version of that comes pre-built with the Recall plugin. Eventually, you'll be able to just download the Recall plugin as an NPM package. We already have a separate repo that has prepared it as so. It's not currently available that way, so you would just have to drag and drop, that directory into your existing ELIZA server if you're already working with one, or you can of course just use the one that we provided. So what I really want to do actually is kind of walk all the way through the whole process of setting yourself up on Recall, and I'll kind of loosely follow these workshop modules, and maybe I'll dive deeper into certain ones depending on interest. But what I really wanted to start with first is just basic setup. And so what I have open is our Recall docs. And what I would recommend doing is installing the CLI. And I already have it locally, but once you have it installed, you'll be able to access different Recall operations. And so what I'm going to do is just create a brand new Recall account and then use that private key, which I'll of course expose to all of you. So it's going to be a completely useless account because we're dealing with testnet tokens. But I'll be using that across the different environments that we'll be setting up. So let me open up my terminal. And that's the one I created earlier. Okay, so once you have the Recall CLI installed, you can just run recall account create. Alternatively, feel free to install your private key or import your private key from your desired MetaMask account. Doesn't matter, but this is the one that we'll create for this session. And so what you'll be able to do is grab that address and head over to our faucet, and you'll be able to get testnet tokens. And and I've already, okay, so I've used this earlier today with the account that I just set up. So I'll just use the account that I set up earlier, which is completely fine. So let me actually go to one of my environments. This is the one that I had just set up. And I'll go back here just to show you a few more operations. And so, let's pretend that we had just set up an account. We can do recall account info, private key. And if you just imagine that I just went through the process of setting up a new account, grabbing that address, going into our faucet, and requesting some tokens, you would see that as your parent balance. And what you would have to do next to actually perform write operations, and what I mean by that are creating buckets using the objects API with recall, or writing objects to those buckets, things like that. You would actually need to purchase credits, which I've already done. But one of the things I'm going to show you that our plugin already allows you to do is purchasing credits. And so I'll actually hop over to, and I think I included it in, I think it's actually in your starter pack, but you'll notice that you have a few links to different resources within our recall repositories, one of which is the recall starter kit. The recall agent starter. And so I'll actually start with that just because it's the most simple implementation of using recall within an ELIZA server. There's not a whole lot of additional noise, and so I'll just talk through the basic functionality and also the basic setup. So if you clone this, which I've already done and I have it locally, what you would do is actually use that private key you just set up and assign it to recall private key once you copy your .env.example. And we're prepending it in hex format. I think in the future, what I'll do is just allow users to use either version, and then we'll just self-correct within the plugin logic. But for now, just append 0x to your private key. You'll also need a OpenAI API key. You can alternatively use Anthropic. There's a few that we've experimented with to varying degrees of success for the reason that I'm about to show you as I walk through the setup. So what we have here is just the plugin, the recall plugin, which allows the agent to add objects, buy credits, create buckets, get your account information, different things like that, exposed as actions. But almost more importantly, we have this recall service kind of running in the background. And what it's doing is actually pulling from your logs table within your SQLite or Postgres database, in which with each inference cycle, we're actually extracting chain of thought logs, kind of storing them locally first, and then batching those to recall in JSON-L format. So you can see store batch to recall. Feel free to look through kind of the storage pattern, how we're using JSON-L format, and then kind of appending a timestamp. So when we're actually pulling it back down from recall, we're able to order them, extract the chain of thought logs, and then use that in some creative way. And you'll also notice that we have this utility file, which actually modifies our Postgres and SQLite table structure just to reflect an additional Boolean table column, which allows us to determine whether or not that particular log was synced. And then right now, for the time being, you'll notice that we have two providers. And as most of you know, providers are really meant to pull in external data and then use that to kind of augment the agent's context window, and then allow it to use that information in some creative way. And so that's what we're doing in this second one. We're actually pulling from our recall service and then retrieving the order chain of thought logs through the process I mentioned earlier. And then right now, really in no creative way, just injecting all of those into your agent's context. In one of the versions that I'll show you later, I'll show you how to, for example, do like vector search over a in-memory DuckDB instance, which will be pulling from your chain of thought logs in recall. But for now, this is just like a very naive, simple implementation. The other provider is actually where we're extracting the chain of thought logs on each inference cycle and then storing it in our local database. And so I know this kind of breaks the pattern of providers really meant to be for pulling external data and then inserting that into the agent's context. This is the way we found to always reliably be able to pull and extract chain of thought logs. And so you can kind of see how we're doing that, and then we're actually using the modified table structure from utils when we're running through and storing that in the local database. And then just to bring it full circle, of course, we're relying on. Okay, and I actually forgot to clear out my database earlier, so you're actually kind of seeing some of those existing logs that weren't synced in the previous cycle right before this call actually synced. And so we can kind of go over what this means later, but let me just walk through things where I left off. So we're using the direct client here, which means you can interact directly over the terminal with your agent. And of course, this may or may not represent a real use case. Like maybe you're using the Twitter client or different clients, doesn't matter. But yeah, for this simple implementation, we're just using the direct client. And I feel like I was going to say something else, but let's just go ahead and do some conversing. So how are you today? And you'll notice that I've included a lot of kind of thorough logging just to show what's happening. So we're running inference against our LLM, and then we're actually generating the chain of thought logs in the provider that I showed you earlier, which runs at the very beginning of the cycle. We have kind of a teaser of what those chain of thought logs look like. I'm using SQLite, so it's successfully logged and saved to SQLite, and then it's generating text and responding to me. And one of the configurations that you'll be able to set up is the batch interval cycle. So I right now I have it set just to the default to 2 minutes. And so if we were to creating another exchange. If we were to wait the full 2 minutes for that cycle to hit, then you'll see it go through the whole process of saving to recall. Oh, it looks like it's doing that now. Okay, so maybe I have the interval set up a little bit shorter, but yeah, found existing bucket. So within our recall service, there's a create or add bucket. And so depending on what alias you use within your environment variable, it'll go and find that corresponding bucket within your recall account, or if it doesn't exist, it'll create one for you. And then it found that we have one unsynced chain of thought log within our local database. It calculates the size, and then it goes through the whole cycle of storing the logs. And you can actually see the key at which it was stored within the corresponding bucket address. And so this is the point at which I'll actually go and show you what this looks like in our portal. So let me head over to the recall portal. I'm going to have to add a new account. So let's do that. Okay, so it's account 20. Let me disconnect. Oh, good. Yeah, we want account 20. Okay, and I'll go to my buckets. So this is the one that the starter kit automatically created for us when we started up the server. And then you can also see within here we have 2 chain of thought logs. So the latest one was this one that was just created. And then you can see the blob hash, the byte size, which matches the calculation that our server environment did, and a bunch of other information. And you'll also be able to look up the transaction hash within our Recall Explorer as well. So, so yeah, that's a quick walkthrough of just the really basic implementation of using the Recall plugin within an ELIZA server. And one of the things that I created just for fun more recently was an MPC server that is basically providing parity against the different functionality you see. Oh, sorry, the one thing I didn't show is like, if you want to use some of the actions, of course, you can say, buy me, I don't know, 0.1 recall, 0.1 credits. So just testing out a few different of the exposed actions. So it's buying the credit for me. The validation for that action handler passed, of course, which we showed up here. And then it's just giving me the transaction hash of that result. So you can kind of do the same with a bunch of the other actions that we've exposed. You can get objects. You can even, so within this get object one, it'll actually create a downloads directory within the working file system of your repository. And then when you fetch that object, it'll download the object, which is pretty cool. You can check your balances, you can do different things. And so what we wanted to do was create kind of the same functionality in MPC format. So you can kind of converse with your cursor environments, your Windsurf, or Claude directly, just using the same kind of action structure. And so what I'll do is actually set it up using the same account. By the way, this also lives within our Recall repositories, and I think I have it here already. Okay, cool. So we'll, once you have this downloaded, you have your dependencies installed, and then there's 2 different ways of setting up your environment. So you can edit the .env, and this is used as a fallback by whichever consuming environment is using that MPC server. Let's say I'm setting it up in Claude. So I'll just open up that config, and then we'll add in that same private key. Cool. And now if I go into Claude, oops, that's not Claude. You can kind of converse with Claude the same way that we were with our ELIZA server. So for example, how many recall credits do I have? Yeah, and so it's pulling the same information. You can also say create a new bucket, a new recall bucket for me called new bucket. And you can similarly use this, like I said, within your cursor environment or Windsurf. And cool, so it's created that bucket for me. This is the bucket address. And yeah, it's ready to use. So for you building within this hackathon, you could of course use you're not constrained by any means to use our ELIZA plugin. You can use MPC format as long as you are accessing recall and writing chain of thought logs. If you want to qualify for an agent-specific bounty, and then for open source tooling, that kind of has a more open-ended approach to constraints. Let's go back to the workshop modules. So I feel like I went through a lot of these. Maybe I'll just call out a few other implementations that you might find interesting. So let me see. So we've worked with Collab, which has created their own agent starter kit, and it uses certain things that are built in, like the Collab plugin, lit actions for programmatic encryption and decryption. And then we've created a version of it that's currently a pull request into their starter kit that uses recall to store protected or encrypted memories, and then pull those back down and programmatically decrypt them based on different access control conditions. And so feel free to absolutely use this. I have it locally, which I can just quickly walk through. This is the same one, the agent starter kit. And so you can kind of see how the actions are structured, the lit actions. We have an encrypt and decrypt using lit. And then this implementation using the recall plugin is a little bit different because it actually spins up a DuckDB instance in memory. And you can check out the table structure here if you're interested. And so what we wanted to do here is kind of showcase how, let's say you're writing chain of thought logs not chain of thought logs. In this case, it's actually just it kind of like replicates the memory table structure from ELIZA. And so let's say you wanted to write those up to recall. And then for certain use cases, like being able to, let's say another ELIZA server wants to pay for access to agent memory from, a different server, you'd be able to use those access control conditions to programmatically decrypt them for that receiving server if they've passed certain conditions, like they've for example like paid for access, which all of which you can define within your lit action, by the way. And then we also wanted to show how you'd be able to use vector search over those entries for kind of like more precise lookup when you're running inference. And so you can kind of see the logic when we're actually querying our knowledge database. So query knowledge uses cosine similarity search. And back in our provider, you can kind of see that we're calling provide knowledge, which wraps the method that I just had on the screen. And so this might be an interesting starting point for some of you who want to go down the route of like, enabling monetization of certain data artifacts, which is definitely something that we're keenly interested in. So I wanted to point this out as another option for people to explore. And then what else? Okay, we also have, I know it's a bit small. There's this alpha agent starter kit that I've created. So it sits again within our repositories. I think it's called Recall Alpha Agent. And if you're interested in, for example, like using Twitter to pull in, crypto alpha, like alpha detection on Twitter, kind of implementing a very specific strategy that we've built out, all of which is explained in the README. And then, iterating through determining whether, based on social signals and API calls to different DEXs and exchanges like Radium, that's looking at like pool size and how long like certain pools have been open for brand new tokens. It makes a determination whether or not a certain signal is alpha or not. And of course, all the time in the background, it's storing those extracted chain of thought logs to recall, and then it plugs directly into Twitter to share those alpha signals. And so I wanted to point this out as it's kind of a more complex but pretty interesting approach. Again, just implementing a very specific alpha detection strategy. So it doesn't go through the whole process of actually purchasing the tokens. However, if you're interested in again using that approach, just yesterday I finished up a trading simulator and a trading simulator MCP, which would allow you to kind of like do paper trading instead of actually using real money. So you can kind of put your trading strategies to the test if of course you're building trading agents. And on that note, just wanted to again point out the competition that we're running, which is based around trading agents. So let me know if you have any questions about that. I said I wanted to leave some time at the end just for questions. So I think what I'll do is actually pause here.
There are two questions while you've been talking in the questions tab directed to you. So the first one is from Grace, who asked earlier, what are the recall credits used for, and will we need them during the hackathon? What if we can't afford?
Yeah, so credits are purchased with testnet tokens, and everything I've shown so far is just running on Recall testnet. So when you go to our faucet, you'll be able to request 5 Recall tokens at a time, and then use those to purchase Recall credits. So it's completely free. Everything is on testnet. And then, of course, if you have any issues going through that process, please let me know. But there's a few different ways you can buy credits. At this point, there's like 4 different ways. You can use the CLI once you have testnet tokens in your account. You can use the agent plugin for ELIZA that I just showed you. You can use the MCP server that I set up. Actually, there's 3. So that's it. But yeah, great question.
Okay, thank you. That's probably very helpful for, I'm sure, other people as well. Aaron asked, and I guess this question is less about what you've been showing us, but more generally about chain of thought. How long have chain of thought logs been used? I first became aware with DeepSeek release, but have been hearing a lot more about them ever since.
Yeah, also a great question. So if you kind of look at both the research in the LLM space and then also where a lot of the more modern frontier models are headed. So for example, if you use Cursor, you'll see that Claude 3.7 Sonnet with reasoning is exposed, and that's because it's feeling like a lot of the technological advances are headed towards self-reflection, chain of thought, and reasoning, and allowing the LLM to go through the process of really producing a quality response based on, being able to observe its reasoning and chain of thought logs. Also, for us as the user, it provides great observability, so you can kind of see where it went wrong, in the process. And so I do this all the time when I'm using Claude 3.7 Sonnet with reasoning in Claude, especially like I just posted yesterday on Twitter, like there's certain things I'm noticing, even if you've set up your Cursor environment correctly using Cursor rules and an instructions doc, where sometimes it forgets to like check existing methods or check your file structure or check like existing libraries that you're already using when it's setting up, for example, like a new testing file. And I've noticed like sometimes it will just randomly choose a different testing library. And so you can kind of look through the chain of thought logs to see, oh, did it first check to see if I have like a corresponding, testing directory in any of my subdirectories within my repository? And if so, does it kind of reference what's already there and then replicate that pattern? So yeah, I think it benefits both, of course, the quality of the output, and then us as people who are able to observe what's happening. In our minds.
That's really interesting, and I hope, Aaron, that answers your question. I have a question. What are some examples of projects or apps or like products that you think chain of thought would improve having? So kind of, you've just given an example there in like working out what went wrong. But can you think of and share some other examples of places where using chain of thought and recall?
Yeah, I'd be happy to. And this kind of points to why we chose to focus on trading agents for our first, it's kind of a hackathon / competition. And that's because in talking to many teams that are building trading agents and then looking at what's actually being built out there, it's easy to understand that, like, the way that you build an ELIZA server now, for example, you have these different plugins and capabilities and skills built in. You also have like a system prompt and a character file for your LLM that it's referencing all the time. And, both for observability, you can kind of see the processes it's going through, like I mentioned before. But I think more importantly, like, let's say 2 different agents are being spun up with 2 different skill sets and character files. And, one is more successful at a trading strategy than another. You can potentially see where, that like less performance server, if they're able to consume chain of thought logs from a more successful one, they can kind of adapt their approach or keep referencing, that chain of thought approach when they're implementing their strategy. And so I think that's for us what we're really interested in. Like, what does collaboration and especially like the ability for agents to be able to monetize based on certain skill sets or subject matter expertise using recall, and then using the chain of thought logs as the valuable data artifact that they're able to reference without actually needing to hard code those skills or hard code or like, for example, bring your agent offline to make changes. I think that's what we're really interested in. But again, just one use case. Like, I think chain of thought and reasoning could be applicable across many different environments.
That was really interesting. Thank you. Do we have any other questions from the chat? This is a really good opportunity to ask Mark live. Otherwise, he will be available, of course, asynchronously throughout the hackathon. So if you're still kind of thinking up your ideas and you want to talk to Mark later, then that is also possible. I'll check the chat. Doesn't seem like anyone is typing, but I'll start to wrap up, and if anyone has a last minute question, then of course we can go through it now. Thank you everyone for joining us again for our final workshop in the AI Blueprints Hackathon. Now we get to the fun part. We have 3 weeks of building. So I'm really excited to see what you guys are all thinking about building, and as you start building, the problems that you end up facing and how you end up fixing them. I'm really excited to see what you're going to get up to in the next couple of weeks. The mentors are all available asynchronously, and potentially some office hours and mentorship will happen midway through the hackathon. So really make sure you're making the most out of their support, because the best projects come from the support of the mentors. And if you want to build something really cool, then the best people to talk to are the ones who know the tech best. So make sure that you're using all that support. And get started as early as possible. Don't leave it to the last minute and then end up in a rush at the very end. If you have time now, start building now. The fact that you've been making it to these workshops live means that you're being really dedicated, which I love. And if you are watching these recordings, but you're watching the recordings, that also shows dedication. So you've put in some time already. Make sure that you're working as hard as you can, and I'm sure you're all going to build some really, really cool stuff. It doesn't look like we have any more questions, so we will wrap up for today. Thank you for joining us, especially on a Friday. Thank you, Mark, for joining us on your Friday as well. I hope it wasn't at an inconvenient time. Otherwise, have a good weekend, everyone, and enjoy the rest of the hackathon. I'm sure I'll be speaking to you all very soon.
Thank you all.